From Chicago, welcome to 3Degrees Discussions. I'm your host, Mike Vasquez. This is a podcast devoted to the stories behind the innovators, entrepreneurs, and leaders of the 3D printing industry.
Talking about structures to a lot of people, sometimes it's not the most interesting thing to capture people's attention and get people to on board to fund what you're doing. So I've had to work with minimal resources through the Air Force, and one of the ways I work with minimal resources is to fail fast and learn even faster.
That was Onome Scott-Emuakpor. Onome is currently the founder of Hyphen Innovations, a company he recently started based on the work he started at the Air Force Research Lab on gas turbine engine designs. Onome received his BS from Wright State University, where he studied mechanical engineering while competing on the men's basketball team. He received both his MS and Ph.D. in mechanical engineering from the Ohio State University. Before we get started, head over to www.3degreescompany.com and subscribe to the podcast. And we can listen to the show anywhere you download your podcast, including Spotify, Apple, Amazon, or Stitcher. Also, if you or your team are looking for materials qualification or general additive manufacturing support, reach out to us here or through our website or via email at info@3degreescompany.com.
Onome, thanks so much for joining the show today. We're excited for the conversation. I saw you talk at IMTS. Love your story, and excited to kind of share kind of what you're working on with the audience today. So I like to start these conversations to place some context, to like go back way to the beginning. So kind of where'd you grow up? Where were you born? Kind of what got you started on the path towards manufacturing, kind of liking to work with your hands and seeing how things work?
First, thanks for having me. It's always nice to know that that people want to talk to you and people want to hear from you. So I really appreciate having this opportunity. Where did the start? So the start, I was born in Lansing, Michigan. I like to say born and raised, but I wasn't fully raised there because when I was 3, I moved to Nigeria, lived there for about 6 years, and then from there I moved to England and lived there for about a year or so before moving back to Lansing, Michigan. That's kind of a very dynamic upbringing in different cultures. I'm a first generation American. My parents were born and raised in Nigeria. So I have this very broad scale of cultures that kind of influenced who I am. Growing up, I never, was really into technology per se. I mean, I was, but I never grew up saying, oh, this is definitely something I want to do. Like I want to, build, robots, or I want to, build cars or whatever. I never thought that. Weirdly enough, one of the things that really captured me, and also, I mean, till today, I bring it up, is the movie Real Genius with Val Kilmer. Laszlo Holyfield was was a character. I was like, man, I really would love to have a layer like Laszlo Holyfield. And at the time, I was just like, I just would like to have a layer. I didn't really correlate that to being a guy who worked in a very secluded lab and focused highly on his technology. But then when I got older, when I got to college, when I started working at the Air Force, and working in my structural engineering lab, the lab is actually a modular building inside a building. So, you go into the building, you don't see the outside world. Uh, it's, if you go in early in the morning in the wintertime and you leave in the evening, some days you don't see the sun. So, so it's one of those buildings, and like I was like, I really like this place, and it took a while before I connected the two. Like, oh, this is like, Laszlo Holyfield's lair. It's probably why I like it so much. But but yeah, I didn't really grow up, wanting to dive into technology. I just it was one of those things where it was kind of like a natural progression. Like I was I was good at math. I started taking math classes. I decided, uh, my dad steered me towards engineering, so I went from math to engineering. Started working in the lab, started tying the dots together, and all of a sudden, I just kind of ran with it.
That's awesome.
So, yeah.
And so, part of that journey you were talking about at IMTS was also around kind of sports and basketball. So how did that tie into what you were doing on the just kind of the academic journey as you're starting on? I think I resonate with that. I played baseball growing all the way up and in college, and I think there's a lot of different lessons that you can take from playing sports and being in as part of a team to complement what you learn in the academic realm.
Yeah, there are so many connections with sports uh, and academics and teams that, as a kid you don't really tie them together. You don't realize that you are taking uh, lessons, or you're taking philosophies from sports and applying it into the classroom. Like, it doesn't really register. But yeah, I played basketball. I started playing basketball when I was 12. Played all the way through, middle school and high school. Got a scholarship to Wright State. Played there for 2.5 years ish. I got injured like right before my third year started, but played through it until I couldn't anymore and focused on school. But one of the things that I got from sports was repetition, that applied to academics and also applied to professional life as well. Uh, One of my favorite videos to watch is like this, Steph Curry hits a game winner, and they zoom in on the shot, and his eyes are closed as he's shooting, because like there are like three people in his face. And everyone's like, "Oh my God, he shot with his eyes closed. He couldn't see anything. How did he do it?" It's like, well, he's probably shot that shot, thousands of times. Probably shot it hundreds of times just the day before, And so it's like, once you built that repetition, it's like, all of a sudden these things, when you actually apply it, it becomes second nature. And that was actually what I did when I studied for my qualifying exams. I just did the same type of problem over and over and over and over again. and so when it got time to actually take the qualifying exam, I was like, oh, I know how to do this. Like, it just because I built that repetition. But that way of studying, just doing the exact same thing over and over again, I think I got that from basketball, where it's like elbows in, release, rotation when you shoot, over and over and over again. And so repetition, I would say, was one of the things that I really took with me, even down to when you're setting up a test. You go through all your checks. You check all your monitors. You check all your sensors. You check all your limits, so that you don't put an extra zero in there, and all of a sudden, instead of pulling at 1,000 pounds, you're pulling at 10,000. Like, it's that sense of repetition, always going through the same process, is very much sports related. So that's one of the main things, is just that discipline of repetition.
And so can you walk us through a little bit of like, as you got into college, you're playing basketball and you're kind of studying hard. What was kind of your thinking in terms of kind of what degree you were looking at, where you wanted to go in terms of academic paths and graduate school, things like that? What were you kind of thinking at the time?
So I went to school to play basketball, and be honest, and school was just the vehicle to playing basketball. Um, so like I did the work to get the grade to play basketball. I did that for 2.5 years, um, and then after I got injured, after kind of uh, trying to figure out, all right, what do I want to do in my life? Then even then I was like, oh, I got this far in school, you might as well keep passing classes, right? And I did that all the way until I started looking for a job, and at that point everyone was like, what kind of job do you want? What do you want to be when you get older? And I was like, I have no idea. That's why I need a job. I want to at least check things off a list. It was kind of my thought process. Like I'll work here. If I like it, I'll stay. If I don't, I'll check it off the list and go get a job somewhere else. And I applied at different places. I looked at like machine shops.
And what were you studying? What did you study as an undergrad?
Mechanical engineering.
Okay.
Yeah. So I went into mechanical engineering. The main reason I went into mechanical engineering was because I had the other thing that I was interested in as a kid was art, and I was told that in mechanical engineering you get to have mechanical drawings. I didn't, I was like, all right, well, sure, that seems close enough. So that was like literally the only reason. But then I when I got injured, I was like, all right, I got to figure out what I want to do. So I looked at machine shops, I looked at automotive industry, I looked at uh, some computational modeling jobs, and ultimately landed a job in a structural integrity lab, which just so happened to coincide with all the classes that I did well in. Was strength of materials and dynamics and statics, and I was like, all right, well, these are the classes I did well in, so maybe this is the place for me. And then started learning about turbine engine structures and structural integrity there, and testing, and once I started learning more about that, it was like, I think this is what I like to do, but I still didn't really know about jobs. So because of that, it was kind of like, well, I don't know where I'm going to work, so I can just go get a master's, and someone's going to pay for my school and then pay me, and I just get to keep doing the same thing I'm doing in this lab. So I did that, and then I got done with my master's, and I still didn't really know what job that I wanted to do, but I knew I liked what I was doing. So again, the same thing. I was like, well, I might as well just get a Ph.D., get paid to go to school, and keep doing what I'm doing. I did that. Got done there. I was like, I still kind of don't know. Oh, there's this postdoc that lets me do the same thing, but not take any classes at all.
Yeah.
And I get paid way more. It's like, well, the joke's on you guys. All right, I'll keep getting paid to do the same thing. And then, when I finally got a job as a civilian with a research lab, even still was I remember asking my boss, so what do you want me to do? And he's like, I don't know, just keep doing what you're doing. It was, it's like, oh, so, okay, so I'm just going to keep doing the exact same thing I've always been doing. And so for 21 and a half years, I've kind of been doing the same thing. It's just that as my knowledge base evolved, so did the impact of the work that I did. I went from, just running a few coupon specimens, not really understanding the details of what I was doing, to, all the way to understanding the manufacturing, the materials, the design of a turbine engine component. But it was the same exploratory activity from start to finish. So. Yeah, it's it's not the ideal journey, but it's been relatively stress free for me because I feel like at every turn I was always excited and eager to advance and learn more as I worked.
And taking that repetition mantra to heart, right? Like keep doing,
Yes. Yep.
work on getting more knowledgeable on what you're doing. So,
Exactly.
So one of the last steps that you mentioned in there was kind of jumping into the Air Force Research Lab. For folks who may not be aware of what that is, or like what's its function at a high level, do you want to just give a couple minute overview of what is that organization and what sorts of stuff do you do there?
The Air Force Research Lab is the initiator for transition in technology that supports the air dominance mission for the Department of Defense. And when I talk about transition of technology, I'm talking about like from just the concept, guys sitting around and saying we should look at this because it, on the back end supports this specific need for a defense strategy for the Air Force. And then taking that concept and turning it into a real thing, essentially going from 0 to 1, like the Peter Thiel book where he talks about, going from 0 to 1. That's the going from 0 to 1 is the largest leap that you can have in technological advancement, because at 0 you have nothing. You have a bunch of guys talking at a water cooler or something. Like you have nothing. And going from that to actually having something, having a tangible, finding, that's the biggest leap that you can make. It's an even bigger leap from 1 to 0 by any number. You're going to get 0. You have nothing. So AFRL is essentially going from that 0 to 1, where we're taking concepts and turning it into something valuable that can then potentially be transitioned into a final product or system that benefits the Air Force's mission. So they're different. Obviously, they're different technologies, all relating to the air dominance, human factors. Where I worked, my entire life was in propulsion and propulsion structures. So when I talk about doing material testing and going from that all the way to a structural component, that is essentially going from that concept to actually having something in hand that can support the Air Force strategy. So yeah, that's I don't know if that was a description that someone from the Air Force would actually give, but that's how I see it. It's taking this up from concept all the way to transitionable item.
And are the folks that like yourselves in AFRL, are they kind of subject matter experts that are like pointed at different directions, missions, programs, whatever you may want to call it at different times? So are you working on like a couple different things? Or are you like laser focused on this system for this vehicle, this plane? Yeah. Like, is it kind of a big organization that like you're kind of working within?
Yeah, it's a large organization, and every portion of AFRL has their own strategy of how they want to advance technology. For the propulsion guys, for turbine engine guys, it's really what propulsion system best matches a specific need for the Air Force. So kind of taking a small portion of that statement and the turbine engine propulsion needs, taking that and applying that to translating that to what I'm doing as an entrepreneur. One of the key strategic needs for the Air Force is low-cost assets. You think about America's military assets, and when it comes to the Air Force, a lot of the cool, publicly known ones are, the, F-35 or the F-22, and it's like, oh, these are, great assets, and like no one can compete with these, but you look at the cost of it, and it's like, well, no, like you can't lose one of those, So it's like it's almost like having having some $8,000 sunglasses on, right? It's
yeah, you need some Ray-Bans, right?
Yeah, that guy, those Ray-Bans are the best sunglasses in this room. But that guy is also like clutching those Ray-Bans pretty tight. He can't lose them, right? So it's like, maybe you need like 20 gas stations sunglasses. So
Yeah.
if you lose it, you just go back and get another one. And so what I'm doing is essentially looking into developing low cost assets. And that's a specific mission for turbine engines and the Air Force, is looking into low cost assets, like we've done the really expensive, adaptable, propulsion systems, and now it's like, all right, how do we make things really cheap? How do we make it so cheap that if you lose it, or if you break it, or if it doesn't perform as intended, then you just kind of shrug and you just go with the next one. Mm-hmm. Or you make it so cheap that that you're not dealing with supply chain issues, or you make it so cheap that it has components in it that aren't reliant on some foreign entity to provide it to you, and then if there's a war that comes out of nowhere, your prices don't get driven up by 2-3x. It's and so that in itself is, and it sounds like a very trivial mission to fulfill, but it's trivial is
it's game changing.
That would apply to it. It's absolutely game changing to make something really cheap that's effective.
Yeah, because you have strategies can be different, right? If in terms of what you're thinking about from a deployment of resources and vehicles, and then also, I mean, like what you kind of hinted on it there. Maybe probe a little bit more on this, but when you think of making things low cost, there's a couple of ways. Like there's numerous ways to think about making something low cost, and I guess where's the focus area for you? Is it kind of a better design, so you're maybe using less materials? Is it let's make it so simple that a machine shop can, or some low cost manufacturing outfit can really do this locally? Like where's kind of the approach that makes that it makes the biggest bang for your buck when you're thinking about making something that's low cost?
It's a combination of a lot of everything you just said. It just for me, in my business, I'm Hyphen Innovations. We're trying to attack it from several different fronts. We're attacking it from how do you make an asset low cost based on the maintenance that's done on it? It's like, all right, if you reduce the cost of maintenance, then all of a sudden it's lower cost than it used to be. Yeah. Or if you develop a viable, comprehensive repair process for a component, now all of a sudden the cost of maintenance is also down because you don't have to purchase so many spare parts. And then you can one of the other ways we're looking at it is we're trying to also develop manufacturing processes that are low cost. So we're looking into metal FDM processes that are taking the same concept as desktop metal and Mark IVs, and we're looking at it from an even cheaper perspective, cheaper furnace, a cheaper printer. And in that way, all of a sudden, it's like, instead of spending $250,000 on the resources to manufacture these components, now you're spending a fraction of that, and you can fill a room with manufacturing capability of 10x of what you would get on the current market with this rapid manufacturing capability. You can make a whole bunch of parts really quickly and deliver them. We're also looking at it from a weight perspective as well. Where you have current systems, can we make the current system perform the exact exact same way as far as power, but make it lighter? And if you make it lighter, now you can now you have better fuel efficiency. You have better payload capability. So it's those are three ways that Hyphen Innovations is actually looking at it. We're looking at it from a maintenance. We're looking at it from reducing the resources required to manufacture, and we're looking at it from a weight reduction perspective. Those three things are high on the priority.
Yeah, I mean, I think that's right on. I mean, one thing that we see a lot on the kind of qualification side is that some of these systems are so expensive and just to buy, not even to run, that it could take, and they're complicated in a lot of ways. Like some of these metal systems where it could take 18 months and $1.5 million to qualify a single material and a single machine like that. That has its place. There are certainly going to be applications for that, but there's this whole area that you're playing in where, okay, can we de-risk this by making it low cost and making trade-offs and realizing like, hey, like if it crashes or like we don't want anybody to get hurt, but if the vehicle itself is destroyed, and not in the world, we're gonna...
and that's one. You brought up a very good point. When we talk about lower cost asset, a lot of times it's not attached to a man-rated system. That's one key thing that shouldn't be mentioned, because it's like, people are like, well, I don't want to get on a cheap plane with cheap parts. It's like, no, it's a lot of stuff that we talk about when we talk about low cost. It's not man-rated things. It's maybe it's equipment transport, could be munition, it could be surveillance and reconnaissance, just whatever. It's just how do we reduce the cost, where if we lose this thing, it's not the biggest it's not the biggest deal in the world. We can print another one because we have we have a 10 by 10 room with 5 printers and furnaces that can print out 5 parts and have them ready to go in less than 48 hours. So yeah, it's most of the low cost stuff is focused on autonomous vehicles and non-man-rated vehicles.
And so you mentioned a couple of times, but like you're kind of transitioning out of the Air Force now. You've got kind of jumping straight into the startup world. So talk a little bit about that journey and kind of where you are and what you're looking to do there.
So that journey started with the development of a vibration suppression technology, where we developed a technology that leverages powder metallurgy from additive manufacturing, and strategically places it within a very small volume of a component, and is able to suppress vibration by up to 95%. And by suppressing vibration, you're suppressing the vibratory or fatigue failure mechanisms that can be detrimental to components by 95% as well. So started with that, and then the Air Force has it's a pretty cool program. It's called the Entrepreneur Opportunity Program, where if you created Air Force technology that that you believe is a transitionable technology, and Air Force gives you a year to explore the commercial space and see whether you can transition this technology and develop it in a way where it's got dual benefit both for the Air Force and as just the commercial space as well. And so I've taken that vibration suppression technology. I've gone through the program. I've identified several places where this technology can be applied specifically for low-cost applications, for maintenance, for using low-cost manufacturing capabilities, and also for reducing weight. I've explored these commercial spaces, and as of this month, I am now 100% operating Hyphen Innovations, which is the company that is going to be the transition vehicle for this technology. And
congrats.
Thank you. It's been quite the journey. I've been doing the same thing for 21 and a half years, and now I'm essentially starting from scratch. But I'm pretty excited about it, just because I'm excited about the technology. I'm excited about being able to transition it, and I'm excited about how it can be applied to helping the Air Force meet their defense strategy missions. So that's been the start of my journey. We have investors. So that's always a good thing to have when you have a startup. So we have investors that are supporting us, in every aspect, from just a business perspective, business development, infrastructure. So yeah, we're ready to hit the ground running in the next few months and start to produce some pretty good technology from using our accelerated R&D processes, low-cost manufacturing, and also accelerated design of turbine engine components.
Fantastic. And what's one or two of the lessons you've learned from kind of being in AFRL that you've kind of want to transition into how you run your business as you get it started up? Do you have a philosophy that you're trying to, maybe not just AFRL, but kind of your entire kind of career? Like, is there a philosophy that you're trying to follow?
Yeah. So one of the things that I got out of the Air Force, mainly that this has to do with the amount of funding and the resources that were available to me as a structures engineer. Talking about structures to a lot of people, sometimes it's not the most interesting thing to capture people's attention and get people on board to fund what you're doing. So I've had to work with minimal resources through the Air Force, and one of the ways I work with minimal resources is to fail fast and learn even faster. And that's the same thing with sports too, right? It's like, sometimes you can overthink how you're going to, play the other team, or you can overthink how you're going to do this play, and then you get out on the field or you get out on the court and nothing is like the way you planned it.
It's like the Mike Tyson quote, right? Like, you can have a great plan until you get punched in the face.
Exactly. Everybody has a great plan until you get punched in the face. And it's like, and for me, it's like, well, I'd rather get punched in the face and figure out how you punched me in the face, and then stop you from punching me in the face the next time. So it's
Yeah.
kind of, that's what I've learned working in the space I was working with minimal resources. Is all right. I'm gonna go out there. I'm gonna try to address this problem the best way as possible, and then I'm gonna uh, take my lessons learned from this application and do it better the next time. I feel like that's the best way to kind of understand what you're getting into, is to go out there, get it done, and then once you get it done, dissect everything that happened and come back and optimize it. It to me, you go through less iterations when you just go out there and do it.
Yep. And you have that debrief at the end too, where you're actually willing to learn and listen. Like, hey, like that wasn't the right thing, and then that's awesome. Cool. I mean, one last question. I think we have a pretty wide-ranging audience, people at different stages in their career. What advice would you give on kind of exploring a career in advanced manufacturing and kind of getting that first step in the door?
Well, it depends on the stage that you're at, but I mean, I would just follow up on what I just said. Really, it's just go out there and do it. Sometimes people, and I get this a lot with some younger students, where it's like, well, you tell me you're an engineer, it's like, oh, you must be really smart, or you must be really good at math, and it's like, what? And I just wanted to do it. Like, take the really smart and the really good out of it and just do it. If you just want to do it, you'd be surprised how far you get. And also, when you actually get into it, you'd be surprised how little all the people that you thought are really smart know. So it's just like, so a lot of people get intimidated about how smart you need to be, or how good you need to be at one thing or the other. And it's like, you just need to get into it. You just need to do it. If it's something that you want to do, go out there and do it. You may not get the results you want the first time, but if you want to do it, just keep on with the repetition, and eventually it'll be second nature. So that's my advice. Just, there's going to be a lot of fear. There's going to be a lot of hesitation. You might even have a lot of people tell you you can't do it, but if it's something you want to do, you just got to go out there and do it. And once you jump in, it's like, just fight your way until you make it to the shore.
For sure. Awesome. Well, if people want to find out more, or get in contact with you, or interested in what you're doing, want to find out maybe how to collaborate or kind of work together, or purchase some of the stuff that you guys are working on, where can they go? How do they reach you?
So you can go to our website. It's www.hyphenmade.com. And there's a mailing list on there. I'm also on LinkedIn. People can contact me directly on LinkedIn. But yeah, those are the two easiest ways to get a hold of me, get a hold of Hyphen, and trying to collaborate with us is mainly go to the website or contact me on LinkedIn, and we're happy to engage with anybody that's in this space, and that's dedicated to leveraging at advanced manufacturing and trying to reduce weight and reduce costs and how we currently do things.
Right on. And we'll put the links in the all the posts that we throw up on the website, so check it out there. So thank you so much for the time. Excited to see where this goes and all the progress you guys are making.
All right. Thank you.